All right, so this is a request 7579, and this is actually a good problem to take a look at because often it's more important to know why you shouldn't do a method versus why you should do a method or how to do a method. So one tactic, and I'll write this in red because this might not be the best, this is not the best tactic actually, but one tactic is to do a U sub initially. Now, while the initial U sub is not bad, so if you do a U sub of like U equals sine of x here, which is incredibly attractive to do, you'll get du is equal to cosine of x. And then when you substitute that in, your integral will become the integral of x u squared, sorry, du sine, cosine of x, du is equal to cosine of x dx, sorry about that. We have the x, we have sine squared that turns into a u squared, and we've stolen away cosine of x dx for a du. Now, it's incredibly attractive here to say, well, wait a second, I have some extra work down there. I have, let's see, I have an x here, but I have a statement that u is equal to sine of x, so therefore x could be written as the sine inverse of u. And that's where you actually have to stop here. Because if you take a look at the original integral, there are no limits in this integral, none at all. And so we don't know what x is ranging from. It could, because the domain of sine and cosine here are negative infinity to positive infinity, and same thing with this polynomial, that means that our limits could be anything we want. However, if you make this substitution and you let x equal the sine inverse of u, that means that x must be always and forever between negative pi over 2 and positive pi over 2. And so that's kind of a big no-no. You can't do that. So you have to think of another way to do this problem. Most people probably wouldn't notice that and would still barrel forward, and they would incorrectly get the correct answer, actually. And the incorrectness of their correct answer would come in the form of the fact that they're taking square roots of things that are actually negative, and they'll end up with some absolute values. They should, actually, in the end. So how can you rewrite this instead? Well, a better way to do it, I'm going to erase all this, is to do it by parts. So pretend as though that second group here, this guy right here, is a function, and this first group is a function. Okay, so you have a group that you're going to call u and a group that you're going to call dv. One group you'll integrate and one group you'll differentiate. Now, it may not be terribly obvious here, but you actually can integrate that second group, and you can easily differentiate the x. So, in fact, when you differentiate that x, the x completely transforms and disappears, and that's what you want with the thing you're differentiating. You want that differentiated item to disappear, and you want to integrate the biggest piece you possibly can. And so there is a way to integrate a sine squared of x times a cosine of x dx. You would have to use a u sub to do such. And it's the same u sub we were actually going to do to find the antiderivative. So I'm going to write this in green now because it is actually a proper u sub now. And you'll see why. If I let u equal sine of x when we're about to take the antiderivative, then du will steal away. I'm sorry, I can't use u's here because u is taken. I'll let w equal the sine of x. If you do that, then dw will steal away a cosine of x dx. And so when you're taking the antiderivative of this, or in other words, when you're integrating both sides of this equation, the left-hand side, the integral of dv, just becomes v. The right-hand side, you're looking at the integral of sine squared of x times the cosine of x dx, but you've just made the substitution and you said, now everywhere I see a sine, it's going to be a w, so that's the integral of w squared, and everywhere I see a cosine x dx, I'll replace it with a dw. And that will become a 1/3 w cubed. And so you know what w is. W is the same thing as sine, so that's a 1/3 of sine cubed of x. And so now we can say this integral in black here is going to equal uv minus the integral of v du. So this is u times v. U is here. U is this guy and v is this guy. So it's going to be 1/3 x sine cubed of x minus the integral of v, which is still that 1/3, du, which is the dx. So minus the integral of 1/3 sine cubed of x dx. Now, it doesn't look attractive, but you can actually integrate this. It's not a terrible integral. It's just one that takes a little bit of thought to do. So you're going to make a trig substitution here. I would love to peel off a power of sine. So in this case, I've already used u's and v's and w's in this problem. So I'm going to let r, I'm just about to use red to do this, but I'm actually going to not use green. So let r equal the cosine of x. I'm sorry, cosine of x. It's perfectly fine. Which would imply dr will steal away a negative sine of x dx. And remember, that's what we want to do with a trig substitution like this, is that we are reducing the power of our integrand by 1. And so when you do this, let's go ahead and steal away a sine x dx. We'll trade out for a negative dr. Let's go ahead and rewrite this. So we have 1/3 x sine cubed. That hasn't changed. And now minus 1/3 of that integral. But that integral, I'm going to write minus 1/3 times that integral. But we're going to steal 1 power of that sine away. So we're left with a sine squared of x. And then the that sine that we stole away times dx gets stolen away for a negative dr. I'll put the negative out front to force that to be a positive. And sine squared, that's just 1 minus cosine squared of x. And cosine squared is r, so that'll be our trick here. Now, this is getting kind of messy, so I'm going to actually go down a little bit here. I'll say, therefore, our integral x sine squared x cosine of x dx is equal to the 1/3 x sine cubed of x plus 1/3 times the integral 1 minus the cosine squared of x, and that was dx, or I'm sorry, cosine of squared of, x, and that's dr actually. And remember, r is equal to cosine of x, and so that's going to be equal to 1/3 x sine cubed of x plus 1/3, let's see, the antiderivative of 1 is just r, minus 1/3 times the integral of r squared dr. Antiderivative of r squared is r cubed over 3, so it's going to be minus 1/9 r cubed. A little bit of rewriting with this. But notice when we did this problem, oh, by the way, since I'm doing this, r, remember, is the cosine of x, so I'm just going to resubstitute that right now. 1/3 cosine of x. Minus 1/9 r cubed plus c. And remember, we didn't make any domain restrictions at all when we did this. There was no sign inverses at all. So this is a perfectly fine way to do this problem. Sine cubed of x plus 1/3 cosine of x. We're almost done. Minus 1/9 cosine cubed of x. And then plus c. There we go. And that is the final answer.